Systems of linear equations are two or more equations. You guys have done this in Algebra 1. I think you might have even seen it in geometry. So it shouldn't be anything new for us right now. What we're doing is we're looking at what solutions do they share? What do they have in common? What numbers can you plug in for x and y so that they're the same solution or they work for both equations? One of the ways we can do that is by graphing them. So you'll see I have these two equations, two linear equations here that I want to graph to see what they share. So let me make this a little bit bigger so that I can graph easier. You have to forgive me, my stylus is out of commission, so I need to be careful here. So for my first one, I have 3x minus 2y equals 2. I need to get it so it's y equals mx plus b. So I subtract 3x from both sides. So now I have negative 2y equals negative 3x plus 2. And then I divide everything by negative 2. So I get y equals 3 halves x minus 1. So I graph that. I start at negative 1. My slope is positive 3, 1, 2, 3 over 2. And there's my points. I'm going to go the other way. I don't know where they're going to cross, so I need to make sure that I put enough here so that I can tell that. And then I draw the line. Alright, now I have to go to my other one. I'm going to erase my math here so that I can see my work. My other one I'll do in a different color also. Alright, so now I need to move the x over again. So now I have 2y equals negative x plus 6. Divide everything by 2. So y equals negative 1 half x plus 3. So I cross at 3. I go down 1 to the right 2, and I already see where they cross. So, well, if I can draw my line better than that, I see now that they are going to cross, oops, that they, oh no, what did I just do? Anyway, did you see where they crossed? Oh, yeah, they crossed at that point, and whatever that point was is our solution. So let's go down here. We have a solution of the system. So solution of system is the solutions for both lines together. So wherever they cross, whatever that point is the solution for both lines and would be your answer. So let's try another one. This might be a good spot to hit pause and try it yourself and then go and see if you get the same thing. So let's try. I'm going to move the 2x over, minus 2x, so I get negative 3y equals negative 2x plus 1. Divide by negative 3. Oh no. Do you see why? This is going to be a positive 2/3 x because the negatives cancel, and then I get a negative 1/3 from my y-intercept. So I'm actually going to save that for later to graph because I'm going to make my graph bigger so I can do it easier. And then my other one, let's do that one green. I'm going to move the x over so I get y equals negative x plus 3. So let me again, I'm going to make this bigger so that I can see easier. And my slope, or my y-intercept is negative 1/3 and my slope is 2/3 in blue. So I get negative 1/3. This is off the grid, kind of annoying, I agree. And then my slope is positive 2/3, so I go up 2 over 3, and I won't be on the grid ever here, up 2 over 3, up 2 over 3. And then I could go down 2 to the left 3, down 2 to the left 3. And so there's my line there. Now I'm going to try and draw a good line. You guys can do better on paper. My other equation, my y-intercept is 3, my slope is negative 1. And we'll do that in green. So I cross at 3, 1, 2, 3. My slope is negative 1. And so I really only care about where they cross here. And so if I look, it looks like they cross right there. So my answer is going to be x is 2, y is 1. And that's my solution. If I take that point 2, 1, and I go back to my original problems. Now you don't have to do this, I just want to show you. If I go back and I plug in 2 for x and 1 for y, I'll have 2 times 2, so I'm plugging it in for this one right here, minus 3 times 1 equals 1. 2 times 2 is 4, so I've got 4 minus 3. 4 minus 3 equals 1. It works. And then if I go in the other one, I'm plugging in 2 for x, so now I'm going into this one, plugging in 2 for x plus 1 for y equals 3. And that's true, 2 plus 1 is 3. And that's the only point that's going to work for both of them. So my answer is 2 comma 1. And this is what you're going to do for me over and over again, is you're going to graph these and you're going to figure out where they cross and what points they share. So let's do this again. Let's start with the first one. I'll do the first one in green. I'm going to move the 2x over, minus 2x. So I get negative 2y equals negative 2x plus 6. Divide everything by negative 2. So y equals 1x minus 3. The other one I'll do in blue. So that's this one. I move the 2x over. So I get 2y equals negative 2x plus 4. Divide everything by 2. So y equals negative 1x plus 2. So now to graph. Make it bigger again. Alright, my first one, my green one, is a y-intercept of negative 3 and a slope of 1. So my green one, my y-intercept of 3, and my slope of negative 1. I hope I got that right. We'll double check. But my y-intercept of 3, my slope of negative 1. Okay, so there's my line. Alright, 3, no, I did it the wrong way. Shoot. I bet I can't erase it either. Okay, we'll do it in green, but I'll make it a thicker one now. Okay, so it's supposed to be negative 3, and my slope is a positive 1, so make it a thicker green line. Okay, now then the other line, let's see if I can do this one right. Positive 2 for the y-intercept, negative 1 for the slope. Positive 2 for the y-intercept, negative 1 for the slope. Okay, so positive 2, my slope is negative 1. Oh my goodness, I feel like I did something wrong. But what's happening here, and the problem that we have here, is that it's actually that spot where it's crossing there is not on the grid, which is why graphing sucks, basically. Shh, don't tell anybody I said that. Graphing is not a good way to do this because it's not always going to cross on the grid. Sometimes you're going to get fractions or decimals, and so it's going to be difficult. So if we were to actually figure this one out, it looks like the x value would be 2.5 and the y value would be negative 0.5. But that's all I can really say is it looks like, because it's not specifically on the grid. Alright, so waiting for my slide sorter. Here we are. We're looking at how many solutions. If you remember, sometimes we can have all solutions, no solutions, or one solution. So if I can hit the right button here, we can actually do this. It looks like I have 2 examples and then you're done. So let's do these 2 examples. I'm looking at getting it again. I have to get y equals. You should be really good at this by the end of this lesson. Let's make the pen a little bit smaller. And let's see here. Alright, for the first one, I move the 3x over, so minus 3x from both sides. I get negative 2y equals negative 3x plus 6. Divide everything by negative 2. I get y equals 3 halves x minus 3. And I'll quick solve the other one before I graph them. The other one I'll do in green, so I move the 6x over this time. So we have negative 4y equals negative 6x plus 12. Divide by negative 4. And we get y equals, this reduces to 3 halves, and this is minus 3. So I have, if you notice, shh, don't tell anybody this yet, but if you notice, these are exactly the same line. Now you might whine to me and say they're the same line. I know the answer, but I want you to graph this so that we can see it. So what was the line again? It was negative 3 and then my slope of 3 halves. So I go and graph the line. I've got negative 3 and my slope is 3 halves, up 3 over 2, up 3 over 2, up 3 over 2, or down 3 to the left 2, down 3 to the left 2. So here's what you're going to do. Because they're exactly the same line, there's your first line, and then if you were to do this again, it'd be just right on top of each other. So just put double arrows to show that it's the exact same line over again. Now if we go and do the next problem, Again, I need to get my x on the other side. So I have negative 2y equals negative 3x plus 6. Divide by negative 2. So I get y equals 3 halves x minus 3. And I go to the other one. I'll do that one in blue. Oh boy. I'm going to move the 2 over. This is kind of tricky, huh? The y is in the wrong spot. So now I have 3x minus 2 equals 2y. Divide by 2 everywhere. So then I get 3 halves x minus 1 equals y. So now let's look at these. We have y equals 3 halves x minus 3 and y equals 3 halves x minus 1. So if I do the minus 1 first, so I have 3 halves x minus 1, so I've got a 1, and then I go down 3 over 2, or up 3 to the left 2. If I do that one first, here it is, this is what it looks like. Then I go and do my green one, and if I look at my green one, it's a minus 3 for my y-intercept and 3 halves. So I cross at 1, 2, minus 3, and then my slope is down 3 to the right 2, down 3 to the right 2, or up 3 to the left 2. 1, 2, 3 over 2, 1, 2, 3 over 2, and there's my slope there. And so if you notice, these have the exact same slope, which means they're parallel. So my answer to this would be no solutions. No solutions. And that would be my answer because they never cross, so they don't share anything in common. If I go back up, I forgot to answer this one. These ones, they're crossing completely. Everywhere that they share a solution. So we're going to say all solutions here, or sometimes we say infinite solutions. So this would be all solutions, would be our answer. The graph isn't our answer, we have to actually answer it. And so if we'll finish today's lesson with this, okay, you can get one solution when you graph. To get one solution, you have two lines that cross at some point. That point is your solution. No solutions happens when they're parallel. They don't cross at all, ever. And all solutions, or many solutions, or infinite solutions happen when you have a line right on top of the other line. So you show that with the two arrows. And that means that every solution that one line has, the other solution has. It doesn't mean that that's a solution there, or that that's a solution, or that's a solution. It just means that everything on one line is a solution on the other.